Hello! Yes, and welcome to our Objective 5.3 sample problems where we're going to practice some more dividing polynomials with long division. So let's dive right in. Let's look at letter A here. So to get this set up, of course, our divisor goes on the outside. Our dividend goes inside. So notice here our dividend is missing a term. All right, so I want to be sure to give it that space. So I'll say plus 0x and then minus 3. There we go. All right. Now remember, it's only the first terms we're concerned with. So x times what gives me 7x to the fourth? Well, it would have to be 7x to the third. And then when I multiply that out, 7x to the third times 7 would be 49x to the third. We need to do some subtraction. That'll give me 0. 43 minus 49 would be negative 6x to the third, and bring down our negative 42x squared. So something cool I think is going to happen here. X times what gives me negative 6x to the third? That would be negative 6x squared. When I multiply that out, check this out. Negative 6x squared times 7 gives me negative 42x squared. Now, so when I subtract these things, what am I left with? 0. Anytime we have 0, we can move ahead a bit, okay? Because x times what gives me 0 is just 0. And now look what I bring out. 0x. Well, x times what gives me 0? 0. Look now. Negative 3. X times what gives me negative 3? The degree is too large, right? With x times, we can't do that. Negative 3 would be our remainder. So for this one, our quotient is 7x to the third minus 6x squared plus negative 3 over x plus 7. There we go. All right, let's look at letter B here. I see already in my that this one's going to look a little different, right? So the first thing I notice is that my divisor is a quadratic, and I see in my dividend I am missing the quadratic term. So I need to be sure to have a plus 0x squared there, plus x, and then minus 10. Now, even if our divisor is a quadratic, the process doesn't change. So we'd say x squared times what gives me x to the fourth? Well, that would be 1x squared. Multiply it all out, I get x to the fourth, I'd get positive 3x to the third, and x squared times negative 5 would be negative 5x squared, and that is going to be what I subtract. So I'll get 0 for my first term. 4x to the third minus 3x to the third is 1x to the third. 0 minus negative 5 would become positive 5x squared, and then of course bring down the plus x. So x squared times what gives me x to the third? 1x. When I multiply it out, I get x to the third plus 3x squared minus 5x, and we're going to subtract. So I get 0. 5x squared minus 3x squared is 2x squared. X minus negative 5x will become positive 6x, and then bring down our negative 10. So x squared times what gives me 2x squared? 2. So multiply this out, check this out. I'd get 2x squared plus 6x minus 10 when I do this multiplication. When I subtract that, I don't get a remainder. What does that mean? That means that these are factors of this original polynomial, that x squared plus 3x minus 5 times our quotient, x squared plus x plus 2, would give me x to the fourth plus 4x to the third plus x minus 10. Very cool. Remember, anytime we get a remainder of 0, that means we are dealing with factors. So let's look here. So C, this one is not in standard form and it's missing some terms. So let's go ahead and start with that. So x squared plus x is my divisor. I'm going to have x to the fourth plus 0x to the third plus 3x squared plus 0x and then minus 6. All right, x squared times what gives me x to the fourth? Well, it'd have to be x squared. X squared times x squared is x to the fourth. X squared times x is x to the third, and I'm going to do some subtraction here. That leaves me with negative x to the third. Bring down our positive 3x squared. X squared times what gives me negative x to the third? It would be negative x. So negative x times x squared is negative x to the third. Negative x times x would be negative x squared. Now remember, I'm subtracting a negative here. So 3x squared minus negative x squared would become positive 4x squared. Bring down our plus 0x. X squared times what gives me 4x squared? Well, that would be plus 4. So 4x squared plus 4x, bring down the negative 6. Oh, wait, no. Gotta subtract first, don't I? I will bring down the negative 6. I'm going to get negative 4x and then minus 6. Notice here, x squared and negative 4x. The degree that I'm trying to go into is now smaller than degree of my divisor. So that means this here, negative 4x minus 6, is my remainder. So my quotient for this one would be x squared minus x plus 4 plus negative 4x minus 6 over x squared plus x. That would be my quotient here. All right, one more. Once again, of course, not in standard form. Let's get it that way. So standard form of my divisor would be 6p plus 6. Standard form of my dividend, 36p to the third minus 6p squared minus 54p and then minus 16. All right, 6p times 36p, or 6p times what would give me 36p to the third? That would be 6p squared. When I do that multiplying out, I get 36p to the third plus 36p squared. I'm going to do some subtracting here. Negative 6p minus 36, so negative 6 minus 36 is negative 42p squared, and bring down, of course, our negative 54p. So 6p times what gives me negative 42p squared? Well, that would be negative 7p. And when I multiply this out, I get negative 42p squared minus 42p. I'm going to do that subtraction. Subtracting a negative, remember, is adding. So negative 54 plus 42 would be negative 12p. Bring down our negative 16. 6 times what gives me negative 12? Well, that would be negative 2. So that will give me negative 12p minus 12. Again, subtracting a negative leaves me with a positive. Negative 16 plus 12 would give me negative 4. So my quotient for this one would be 6p squared minus 7p minus 2 plus negative 4 over 6p plus 6. Now, if you wanted, you could absolutely simplify that fraction. We can take a 2 out of everything. You could turn it to negative 2 over 3p plus 3. That would be totally fine. I'm not going to require that, but it is something we can think about, all right? Okay, hopefully after these sample problems, we're feeling a little more confident with our dividing polynomials with long division. As always, if you have any questions, reach out. Otherwise, go ahead and get started on those practice problems. Let's see how we do. This is Mr. Carter signing off. I'll see you next time.